Okay, so now that we've just discussed artificial intelligence on a very high level in terms of what it is and what it's not, let's look at the things that actually make artificial intelligence work. And one aspect within artificial intelligence, and when you think of artificial intelligence, I want you to think of it. Let's make an example. You get mathematics, and mathematics is the overarching field. Within mathematics, you get different type of topics and components, whether it is theorems, whether it is Pythagoras, and all these nice fancy high level mathematics concepts, but all of them fall under mathematics. So think of AI similar to that. So AI is the broad field, and within AI we've get what we called machine learning. I saw a hand raised there. I'm not sure. Okay, so within artificial intelligence, we've got machine learning. And what is machine learning? I think we must have heard of the concept machine learning, but what does machine learning actually mean? So, machine learning is the process of training a model or an application or a computing device with large amounts of data. What that machine learning model then does, it processes that information, it identifies patterns and trends, and due to that patterns and trends, it's then able to make an informed prediction. Okay, and a prediction is what's important, and I want us to focus on. So it's predicting what could be, or what could be the right answer, what could be the way forward. So as we can see, when we think about machine learning, we're looking at data, we're looking at patterns, and we're also looking at relationships between those different type of data components. Okay, and we can look at it, especially when we think about it in a class setting. We might have a number of learners, 20 learners, but these 20 learners are taking the exact same test, but not all of them are scoring the same marks. But there's also a relationship between certain of those individuals, why some are scoring high, why some are scoring low, and why some are scoring in the middle. Whether it be their friend group, their background, or their type of learning niches, whether are visual learners, whether are audible learners, and those type of aspects. But machine learning's all got to do with the processing of large amounts of data, analyzing that data, recognizing patterns and relationships, and that is what's going to inform the machine learning model in order to make a decision. But there is a slight type of limitation when we think about machine learning and think about um, version 2 of machine learning, and that's called deep learning. Okay, so machine learning is only able to work within its parameters or the data that it's being trained upon. So, if this machine learning model is trained for the automotive field, so it's about driving cars, that information or that model won't be able to be applicable for, let's say, flying an airplane. Okay, because those are two totally different, though it's transport models, but there's a whole different type of variables and things to consider when one is flying a plane than to if one's driving on the tar roads. Okay, so machine learning does have some limitation in comparison um, to deep learning, which is the advancement or the add-on to what machine learning is. So, when we think about machine learning and its ability to process data and then also being able to give an indication and a prediction, will we now be able, because now we've understanding what AI is on a high level, humans' ability to mimic human, the computer's ability to mimic human intelligence, and now we've also now seen that there's an aspect within AI called machine learning, and that's all about processing data and also then giving a prediction or an instruction. Okay. So for those of us that are still on the Mentimeter. I just want us to maybe just toggle back to that, and let's just give some input, because it seems that if I'm that nobody's very open to have an open dialect. I would also love to hear your voices as well. P.S. Don't worry, I am married, so so I'm not on the hunt for a partner of any sort, but definitely, obviously, like to engage with the spool of now 42 individuals. So for those of us that are able to, if we can just access the www.minty again, most probably be the exact same code. And now we want to know is, what are your thoughts? So calculating the distance to a star, would we use machine learning for that, or is that just a rule-based application? Okay, is it just following rules? Does it just have everything's already preset, or are we going to use an AI model? Okay, so let's just give it a couple of seconds just to get some more input from the team here. But I see a lot of us are leading to the yes. Okay, perfect. I hope we can appreciate the wonderful gifts that we are using. Yeah, I think this is a pro wrestler. I just cannot come to his name now. But it's also a very cute cat. They're shaking his head. No, okay. So the majority of the room is leaning to, mm, for me, it's the left. Okay. Yes. Okay. Let's see. Forecasting air pollution. Okay. Here would we make use of machine learning to forecast air pollution? What do you think? No. Okay. Very interesting. Okay. And the balance is also quite nice and even. I see. Okay. Things are changing significantly now. Okay. And that's a very compelling yes give there, shaking his head. Yeah, serious guy. Okay, perfect. So I see the majority of us are leaning to yes, forecasting air pollution does in fact make use of machine learning. And then lastly, let's see, identifying animals in a video. Is this using machine learning? Yes, no, or maybe. Mm, okay. I like that we are having these differences in, especially in terms of our um, thought process when it comes to these identifications of use for machine learning, which I think is very interesting. And I think that also just speaks especially to our group. So we are quite a diverse group here with different backgrounds, but I think we're here because of the one thing that we hold in common, and that is a sheer love and passion for the education sector, the individuals that we engage with, and wanting to skill ourselves and also to garner a deeper understanding of what's actually out there and available for us. So perfect. Okay, nice. That's some good data even that I've collected now. Okay, so let's see. Types of machine learning, calculating the distance to a star, probably instructions. So you might think to yourself, yo, I mean, I think, and especially when you're thinking about it's a star, so it's out of space. So it's always like in terms, sometimes like it's a bond, not a bond, beyond our ability. It's so far away, so it might need some hard number crunching there. Um, but it's all about instructions. I think you use a particular format. Um, I'm not a mathematician by profession, so so you'll definitely use some predefined calculations there. But forecasting air pollution, that's most definitely a machine learning model there. You'll need to be able to access a lot of past data. You also need to also then take into consideration what's taking place in that particular area, what's the industrial areas, what are the levels of production taking place there, in order to inform what the type of air quality is going to be within that region. And for that, you'll definitely make use of a machine learning model. Identifying animals in a video, and this is so very interesting because we look at building a machine learning model here. today, so that we understand especially how these type of recognition models are working. So identifying animals in a video, yes, definitely if a computer is going to do that, we'll definitely, or we could definitely use machine learning there, and you'll see it, and it will start to make a bit more sense when we see how we build a machine learning model. Okay, so types of machine learning. So as you can see, as we are progressing on through the slide deck, we start to see how deeper we're starting to dive within the topic artificial intelligence. So now we see we've got artificial intelligence. Within artificial intelligence, we've got machine learning. And now within machine learning, there are three learning models or learning types that machine learning uses. The most um, not famous one, but the one that we'll engage with today, it's called supervised learning. Okay. And for supervised learning to work, we are going to need to have a lot of the right answers beforehand. Okay. So when we're starting to build the supervised machine learning model, we already predefine what is right, what we are looking for. And now that we've given the right answers or the right types, this model will now be able to identify its characteristics. And when new data is fed into the machine learning model, it will be able to reference that against what it's already been trained upon, and then make informed decisions based on the categories that it knows, or the categories and the labels. So needs data that has been processed by a human and requires a lot of data to train. And you will see why I say that, especially when we start to build that supervised learning model. Unsupervised learning. So this is the process where the machine learning model is not given all the right answers, but it's fed information, and based on that information it's fed, it starts to group certain characters and certain aspects of the data together. So it will cluster and then be able to then give you a response there. And then we've got reinforcement learning. And think about reinforcement learning on a very high level as a lot of trial and error. So the machine learning model knows nothing at first hand, but as it's trained and it gets predictions right, it gets answers right, that's when it's being rewarded. So it is trained to know and to think, okay, right answer, reward, wrong answer, no. And the reason why um, I've got just the penalty um, type of icon there, just because sometimes when we explain reinforcement learning, I like to make the analogy uh, of a soccer match. So it's penalties. So we've got Messi, we've got CR7. They are there. It's time to shoot some penalties, or maybe should I make it a bit more close to home? So it's the Bokke and the All Blacks, but that should maybe be a very sensitive topic just because of what happened this past weekend. So I think I'm just gonna jump back to back to the soccer analogy. So for every time you shoot and try to score a goal, you miss, and the crowd is very angry at you. So you start to learn and see, okay, this ball mustn't go outside of the net. When you shoot and the ball goes into the net, everybody's happy. Okay, so the machine learning model starts to learn and see, okay, ball goes into net. That's the process. That's the right thing to do. Okay, so this model just needs a bit of time in terms of to analyze and to learn what is right and what is wrong. So that's a type of machine learning that machine learning makes use of. Okay, so let's see. We're going to jump into building a quick machine learning model. Just because of the essence of time, um, I will be taking us through it and explaining the processes step by step. I will share the links and some of the resources with you at the end, but just to ensure that we stick to our time, because I really want us just to cover the entire slide deck so that you find value. But I think before we move on, I'll just like to just open the floor just for any comments, thoughts, before we go into just this little practical quickly. I think Zoe, like, our group really appreciates the anonymity that comes with the type of platform engagements like with Mentimeter and also the Kahoot. But um I don't blame you. It's nice to be very mysterious, and especially in a setting like this where we are not familiar with each and everyone in the room. So it's always the fear um of of maybe indicating or saying something wrong. Mark Jabet, can we talk more about AI in education? Definitely, we'll definitely get to that aspect. I always believe that it's very important just for us to really just get an understanding in terms of what the application or the technology is, and the better we understand the technology, the more we'll be able to make use of it within our space of work. Okay. So, can I just move that out of the way quickly and get that like this, and then I can share my screen here. Perfect. Okay, so when we think about building a machine learning model and just understanding that process, I'm just going to build it for us quickly. Yeah, and obviously then just take us through the platform. I think we are making good with time, so there'll definitely be enough time to um, really focus on AI in education. So we're going to build a machine learning model here. So we're going to start a new project and we're going to name it the supermarket AI. What role are we going to give this AI model? The role that we're going to give it is recognizing images. And I want us also maybe just to think as this as an aspect that we could actually run as an activity within our class, because I think it's also important for not just us to understand artificial intelligence, but also for our learners or the individuals, whether it be educators, whether it be after school practitioners, and whether it be individuals that make up our after school activities. Okay, perfect. Can I just want to just ask just a thumbs up if you do see both of my screens as obviously that type of in that share window. So you are seeing the image where we're going to build the model, and we also do see the pictures. Okay, perfect. So we're going to build an image recognition system, and where's our storage going to be? So it's going to be in our web browser. So think of this as an activity that you can run if you have some tablets, if you have devices within the spaces that you're working, and you can really show kids or individuals really how AI works and how it is built. This is on a very high level, so it's good for people that have zero to no experience working with artificial intelligence, or it can be for those of us that are a bit geeky about these things. Okay, so now I'm creating my model. Okay, so here's my little artificial intelligence machine learning model. Okay, so now remember, when we're talking about machine learning, we're talking about feeding a data, training the model, and then seeing how well it predicts. Okay, so I want to train my machine learning model. So first, I'm going to need to tell it what is right and maybe what is wrong. So I wanted to be able to know what is apples and what are tomatoes. So I'm going to give it a label to tell them, okay, so this is going to be apples. So I've added this container, and then whatever is going to be in this container, this is going to be what apples look like. So here's my Apple data. I'm just going to click and drag about 5 images of apples. And it's funny that there's only green apples here. Okay, so here's my 5 pictures of my apples. Okay, I'm happy with it. It shows some apples from different views. So there's a button apple, there's some apple with water droplets. What's the plural form of of a lot of apples, a bunch of apples, of a basket of apples. And now I want to put in my label for tomatoes, tomatoes. Okay, whichever resonates nicely with you. Okay, so yeah, I'm taking some of my tomato images and I'm dragging that to there. Okay, let me see. Okay, perfect. Nice. So here's my categories. Here's my label. So remember when we spoke speaking about machine learning, we are saying that we're already giving it all the type of right answers. Okay. So this is what apples are. This is what tomatoes are. This is what it looks like, and this is what tomatoes look like. Okay. So now I'm gonna say, okay, back to my project. So now that I'm given it these categorizations and the data, it's now start to learn and test our model. Okay. So now I'm going to train my machine learning model. So what's going to happen now? So those compartments that I built now with the images, the machine learning model is now going to analyze it. So it's going to look through that pictures. It's going to send it through like a lot of layers of analyzing the type of shades they use, what it looks like, its makeup. Okay, perfect. So now the model's being trained. Okay, it's going through that information now. And it is taking some time, which is also good. But I think okay, it's ready now. So let's test to see if this model can actually analyze what an apple looks like. So remember, we had our training data there, and now we've got our test data. Okay, and now I'm very interested to see what the accuracy of this is going to be. Okay, so what I'm going to do, and you can see these are totally different pictures to what I trained the model on. So let's take the hand with the tomatoes. Okay, I'm just going to drag that in there. Okay, sorry for that. Oh, no, man. Okay, let me just copy the image URL here. Copy email address. Okay, let me drop that in there and let's test it. Okay. And as you can see, they recognize as tomatoes with 91%. Okay. So remember, we had all green apples. So I'm very interested to see if this model is going to be able to know that this is an apple, seeing that it's has quite a similar look to what the information was that we trained it on, um, being the tomatoes. Okay, perfect. There we go. We've got that. And it actually did. I'm not sure if you are able to see on your screen the type of accuracy that it's getting. So it actually read that apple as apples. And remember, so we're saying it's making this prediction. And now what we're seeing here, so it's recognized as an apple with 87% confidence. But now what we must know within the world of this machine learning model, it only knows apples and it only knows tomatoes. So, for instance, if you were supposed, if you were going to insert an image there of a person, it's probably going to say whether that person looks more like an apple or like a tomato. So, the golden rule here in terms of models, it's the more clean and good data you put in, the more good data you are getting out. So, this type of demo was designed for both educators and for learners, and especially for it to run as an in-class activity. Okay. Okay. So that's how supervised learning works. So let's look just at the diagram. So we inputted the raw data. We used the supervisor model. We trained the data set. It ran through the algorithms, ran through the processing, and we've got the output. So it was able to indicate whether it was an apple or whether it was a tomato. So that's how machine learning models are built, and that's obviously at a very high level. It can get much more, and it is much more intricate than what I showed you. But for the basis and for the fundamentals, that's generally the process of artificial intelligence being processed, and also then being able to make that informed type of decisions and predictions.